Hello everyone, I'm Kirtana from Erode Secondary Engineering College. Today I'm going to take seminar in the subject of brain computer interface and applications in the topic of neurorehabilitation. Let's begin with an introduction. What is mean by brain computer interface? The brain computer interface enables the direct communication between the brain and an external device. It bypasses the conventional neuromuscular pathways, and EEG is the most commonly used signal source in BCI systems. It is used for communication, control and rehabilitation. Next, what is neurorehabilitation? It is the process to recover lost neural function. It helps to restore motor, cognitive, and sensory abilities. It is used after neurological disorders. The BCI enhances the rehabilitation outcomes. Next, we see the need for BCI in rehabilitation. The basic needs are traditional therapy has more limitations and the slow recovery in severe conditions, and brain computer interface provides real time feedback. It also improves the brain plasticity. Next, brain plasticity. Brain plasticity means it is the ability of brain to reorganize its functions. It is essential for recovery after the injury. The BCI stimulates the neural pathways, so it enhances the learning and the recovery. Next, we see the working principle of BCI systems. The brain signals are recorded from the EEG, and the signals are processed and classified. It is then converted into the control commands. The output devices executes the actions. Next, we see the signal acquisition part. The electroencephalography used for the non-invasive recording process. The electrodes placed on the scalp and measures the electrical activity of the brain. It is safe and widely used procedure to measure the electrical activity of our brain. Next, signal processing part. In the signal processing part, it removes the noises and filters the signal. So, it strengthens the signal and we can easily extract the features from that signal. It is mainly used in the pattern recognition, and the machine learning algorithms are also used for the signal processing process. Next, we see the types of BCA system. There are four types of BCA systems. First one is invasive brain computer interface and partially invasive brain computer interface, non-invasive brain computer interface, and non-invasive preferred, and mostly non-invasive preferred for the rehabilitation process. Next, we see the motor imagery brain computer interface. In the motor imagery BCI, the patient imagines the movement. The brain signals are detected at that moment. It is used for the limb rehabilitation. It improves the motor control systems from the brain computer interface in the rehabilitation system. Next, we see the role of BCA in stroke rehabilitation. The stroke causes the motor impairment. The BCI helps to regain the movement, and it also provides feedback from based on the training process. It also improves the hand and arm function through the rehabilitation process by using the brain computer interface. Next, we see the robotic devices that include with the brain computer interface. The major process roles of the BCA in the robotic devices are it controls the robotic arms and the exoskeletons. It also assists the movement training due to that process by using the robotic devices. It provides the repetitive therapy and enhances the recovery speed, so the patient can easily recover. Next, we see the brain computer interface with FES. Functional electrical stimulation. The functional electrical stimulation stimulates the muscles by using the electrical pulses. It activated using the brain signals and restores the muscle movement. It is mainly used in the paralysis rehabilitation. Next, BCA for spinal cord injury. The spinal cord injury leads to paralysis. So, the BCA bypasses the damaged pathways and enables communication and control. It helps to regain limited function. Next, we see the advantages of BCI in neurorehabilitation. Non invasive techniques are available in BCI and it enhances neuroplasticity, provides real time feedback, and improves patient independence. Next, limitations. High cost of equipment requires training and calibration, signal noises and accuracy, and limited accessibility. Future scope. The AI integrated BCA systems, wearable BCA devices, home based rehabilitation, and improved signal accuracy in the BCA systems. Next, we are in the conclusion part. Let's conclude this session by the BCI plays a vital role in neurorehabilitation. We understand from this concept. So, it also helps to restore the lost functions and improves the patient recovery and the independence. The future advances will enhances the effectiveness of this system. Thank you all for watching.